We have learned how to solve fixed beam using 1D beam element, how to create multiple elements, and the concept of node A and node B. In session 9, we are going to learn how to solve a simply supported beam using 1D beam element, how to create multiple elements, and the concept of node A and node B. Now first I will show you the problem statement. So this is the problem statement that we have. A circular tube cross section. The length of the beam is also given, the load is also given, material properties are here, as well as the analytical solution. So this is the analytical solution we are aiming for. Now to solve this problem, let's go directly to HyperMesh. In HyperMesh, first we will select the user profile as OptiStruct. Next, we will create a material. Give a name to the material. Give a color. Type as isotropic and card image as mat1. Created it. Here in Young's modulus we will give a value of 9.6 10 to the power 4 and a Poisson's ratio of 0.36. Now click on return and return. Next we will create a cross section. So 1D page, hyperbeam panel, go to standard section, select the standard section type as thin walled tube and go to create. Here we will define the outer radius as 50 and inner radius as 40. Press F to fit this to screen. Now from here you can also calculate the CDEF points, and let's go back to HyperMesh by going to this icon. Now click on return to exit the panel. Next we will have to define the property. So go to the property icon, give a name to the property, give a color, type as 1D, card image as P-beam, select the material as material and beam section. Now go to create edit, enable continuation line 2 and here define the CDEF points. So once you define the CDEF points, go to return and return. So material cross section property is done. Next is components. So go to component icon, give a name to the component, give a color to the component and select the property and go to create and return. Next we will go to nodes panel under geometry page, create a node at 0, 0, 0, second node at 500, 0, 0, third node at 1000, 0, 0. Click on return. Press F to fit this to screen. Next, we will go to 1D page, bars panel and create the element. So first we will define the property as beam, element type as C-beam, define the orientation, and now we will select node A and node B. So the first node I am going to select as node A, second node as node B. So that means this center node has to be node B. So now I will select the last node as node A and again the center node as node B. Now click on return. Now go to geometry page, temporary nodes panel and click on clear all and return. Now we will go to load collectors. First we will create a load collector for SPC, give no card image, give a color, click on create. Then we will create a load collector of force, again no card image, give a color and create and return. So first we will define force. So go to analysis page, forces panel, select the node somewhere at the center. So you have to click somewhere near the center and it will automatically pick up the node. Next, give a magnitude, in our case 30,000, that is in negative direction, that is negative y. So here we find the axis as y axis. Now click on create and go to return. Next step is creating the constraint. So go to constraints panel, make sure SPC is the current load collector. So right click on SPC and make current. Select the two nodes. Here in simply supported beam, two supports on the end act like pin supports. So rotation is allowed, the translation is not allowed. So here what I am going to do, since the translation is not allowed, I am going to fix DOF1 and 2 and uncheck 3, 4, 5 and 6. So that means the two nodes are only fixed in translation X and translation Y, and then click on create. Now click on return. Now last step is go to load steps panel. Give a name to the load step. Make sure the type is set to linear static. In SPC, select SPC. In load, select force and click on create and return. Now all you have to do is save the file and solve the file. So save model, give the name of the file, now to solve it, go to OptiStruct panel and click on OptiStruct. Once it is done solving, click on results. Now in HyperView, first I will change the plane to XY plane, then go to contour and click on apply. So this will show you the displacement, which is coming as 2.3. Then if you want to see the stresses, change the result type to element stresses. In the second drop down, select the point at which you want to see the stresses. So in this case I want to see the stresses on B node. So we will go with SBC and click on apply. So this is compressive, and here we are getting a value of minus 1.29 10 to the power 2. Next is D point, where the result should be 0. E point, where the result should be positive stresses 129.4, and last is F point, again where the result should be 0. So now we are done with the simply supported problem statement. Now I am going to show you the homework. So for homework, you have to solve the similar problem of a beam. The length, force and the cross sections are going to change. So here are the first 5 sets of problems. Second set of problems, for a total of 10 problems. Now while you solve the 10 problems, make sure you calculate the stresses and displacements both analytically and in the software, and input the values in the last 2 columns. This is just to verify the results. So with this, we are done with session number 9. Thanks a lot for attending session number 9. In session number 10, we are going to cover node, node edit, temporary node, distance, line and line edit panels.